Welcome to the Mathematics MI channel. Today we are going to solve another interesting integral. Integral from 0 to pi over 4 natural log of cotangent of x times sine to the 2020 power of 2x over sine to the 2021 of x plus cosine to the 2021 of x here is square dx. Okay, if you like my videos, please like and also don't forget to subscribe this channel. Okay, how to begin? Okay, first I'm going to define a function f of n, and I'm going to take the general case 0 to pi over 4 uh, natural log of cotangent of x times sine to the n minus 1 power of x over here sine to the here n minus 1 2020. So here we know n of x plus cosine to the n of x here square dx. Okay, now if we plug in 2021 for n, here we know 2021 minus 1 2020, here 2021 2021. So this is equal to our integral. So we should evaluate f of 2021. Okay, now we can write this is equal to integral from 0 to pi over 4 natural log of here 2x natural log of cotangent of x times, now we know here sine of 2x double angle formula, so we can write 2 times sine of x cosine of x raised to the n minus 1 power. So 2 raised to the n minus 1 power sine raised to the n minus 1 power of x cosine raised to the n minus 1 power of x over here in the denominator I am going to take sine raised to the n power of x as a common factor. So if we take sine to the n power of x here square, so we should write sine raised to the 2n power of x, and here we know only 1 plus cosine to the n of x over sine to the n of x, we know cotangent raised to the n of x here square dx. Okay, then here we know 2 raised to the n minus 1 power is a constant, so we can write outside of the integral sign. So 2 raised to the n minus 1 power integral from 0 to pi over 4. Now here natural log of cotangent of x times sine to the n minus 1 power of x cosine to the n minus 1 power of x over, now here this sine of 2n of x I am going to write sine of 2 n minus 1 power of x times sine square of x. Now if we multiply this, we know 2 get cancelled and we will have sine raised to the 2n power of x here. Okay, now next term here 1 plus cotangent raised to the n of x square dx. Okay, then as a next step we can write 2 raised to the n minus 1 power integral from 0 to pi over 4. Now we know here sine to the n minus 1 of x, here we have sine raised to the n minus 1 n minus 1 of x times sine raised to the n minus 1 of x, so this term get cancelled, and now we have natural log of cotangent of x times, now here cosine over sine, so we can write cotangent raised to the n minus 1 power of x over, in the denominator we have sine square of x times 1 plus cotangent raised to the n of x dx. Okay, then what can we do? Okay, now we can take a substitution. So if we take t is equal to cotangent of x, now differentiate, so dt is equal to minus cosecant square of x dx. Okay, now we should change the limit, so we can write 2 raised to the n minus 1 power. When x approaches to 0, we know t approaches to infinity. When x approaches to pi over 4, we know upper limit 1. Now natural log of cotangent of x, we know t, so natural log of t times, now cotangent raised to the n minus 1 power, so we know t to the n minus 1 power, t to the n minus 1 power, over, now here sine square of x, here dx, so dx over sine square of x, we know cosecant square of x is equal to 1 over sine square of x, so here we have minus dt, so here minus sine dt over here 1 plus cotangent, we know t, so t raised to the n power and here square. Okay, then we can change the lower limit and upper limit. When we change the limit, this minus get cancelled, so we can write here this is equal to 2 raised to the n minus 1 power integral from 1 to infinity. Now 1 to infinity natural log of t times t to the n minus 1 over 1 plus t to the n here square dt. Okay, then again we can take a substitution. So if we take now we can take u is equal to t to the n. Now differentiate, so du is equal to n power rule t to the n minus 1 times dt. Also here we have natural log of t, so if we take natural log both side, we can write natural log of u is equal to n times natural log of t, n times natural log of t. Okay, then we can substitute here 2 to the n minus 1, limit we know also 1 to infinity. Now natural log of t we know natural log of u over n, natural log of u over n, here t to the n minus 1 dt, t to the n minus 1 dt we know du over n, so du over n, so here we can write n square, here 1 plus t to the n we know u, so 1 plus u here square. Okay, then we know n square is a constant, so we can write 2 to the n minus 1 power over n square integral from 1 to infinity. Now we have natural log of u over 1 plus u square. So to evaluate this integral, we can use by parts method. So I am going to take natural log of u as a first function, then d by du, then integration of 1 over 1 plus u square, we know minus 1 over 1 plus u du. Okay, then here 2 raised to the n minus 1 power over n square. Now here product of these two functions, so minus natural log of u over 1 plus u from 1 to infinity, then minus, also here minus, so plus integral from 1 to infinity. Now rewrite this function. So 1 plus u, and derivative of natural log of u we know 1 over u, 1 over u here du. Okay, then we know this is equal to 0. So here we have 2 to the n minus 1 over n square parenthesis. Now integral from 1 to infinity. Now we can write this is as a partial fraction, so we can write 1 over u minus 1 over 1 plus u here du. Okay, now we can integrate 2 to the n minus 1 over n square, and here if we integrate 1 over u, we know natural log of u, here natural log of 1 plus u, here minus sign. So according to property of natural log, we can write this is equal to natural log of u over 1 plus u, limit from 1 to infinity. Okay, now we know this is f of n. F of n is equal to 2 raised to the n minus 1 power over n square, and if we plug in infinity, here we know 0 minus, if we plug in 1, natural log of 1/2, and then 2 to the n minus 1 n square. Here we can write natural log of 2 to the minus 1, so minus 1, here minus sign, so plus natural log of 2. Okay, this is f of n. Now we know our integral is equal to f of 2021. So f of 2021 is equal to 2 raised to the 2021 minus 1, we know 2020 times natural log of 2 over here n square, n we know 2021, so 2021 square. Okay, this is the answer for this integral. If you like my videos, please subscribe this channel. Thank you for watching.